Hey, what's going on everybody? It is George coming at you with another video, and today we are going to be answering a subscriber's question. And it's going to be regarding OSPF and the advertising of OSPF specifically. So let's go ahead and go into it. So OSPF, of course, stands for Open Shortest Path First, and it is probably one of the most used routing protocols out there. It's up there with BGP. So let's go ahead and assume that you guys know what OSPF is at this point, but I want to go ahead and tackle the question. And the question is, how would you go about advertising networks within the same network on multiple interfaces across a single area OSPF? So I am going to answer that question, although my example here is not exactly going to be specifically exactly that question, but I believe that if you listen to the lecture here, you will understand. Oh, and by the way, if you really have the exam in a couple days, you probably should want to reschedule it. I think you need to understand this before you can go about taking the exam. So I'm going to have router 1 here. I'm just going to have router 2 and router 3. And they're each going to be connected through a serial link here. Let's go and connect that together. Boom. Okay. And they're each going to have a loopback. And they're all going to be based on the router number. So they're all going to be on loopback 0. And for instance, router 1 is going to be 1.1.1.1/32, and they're all going to be similar. So router 3, 3s, and router 2 is going to be all 2s. Now here in the middle, we have two networks, and they are different networks. They are not in the same network, but two subnets of the same network. They are just two networks. But the reason I want to do this is because I need to explain to you why exactly there really is no big reason to see much of a difference, honestly. So it's 10.1.12.0/24, and this is going to be 10.1.13.0/24, and each of these are going to be represented by so this interface is going to be .3, this interface .1.1, and this is going to be .2. Again, represented by their router numbers here. Alright, so let's go ahead and tackle this. But first I want to go ahead and explain the concept behind some syntax here. So to do that I will use red. Okay, so when you are distributing networks across OSPF, you use the network command. So use network, and then you put the route. So for instance, in this case, it's going to be 10.1.12.0 followed by the wildcard mask. The wildcard mask, let me go ahead and just write this a little further down. It's going to be network 10.1.12.0. The wildcard mask is going to signify what part of this IP address do we actually care about, and what part of that address are we going to advertise. But I want you to think about that, but then I want you to completely erase that from your mind, because when you're talking about OSPF and advertising the address, you're already starting on a bad notion. And this is something that is not really your fault, but it's something that you have to understand, is that OSPF does not advertise IP addresses. It advertises the links connected to those IP addresses. So what do I mean by that? So let's just finish off that command. So I'm assuming you know how wildcard masks work, but to be brief, the zeros mean that we care about those octets, so we care about the first 3 octets, and we don't give a rat's ass about the last octet there. So network 10.1.1.12. So, and let's just go ahead and put an area. So this is all going to be area 0 because this is all just all area 0. So let's go ahead and get another little color here. Let's do pink. So these three here mean that we care about these octets here. So now where do we, if we were on router 1 and we put that command into the OSPF process, it would look at the command and say, okay, router 1, let's go ahead and network any interface that matches 10.1.12. That's it. And in this case, this interface matches. And that's the only interface that matches that specific prefix. So if you had another network out here, in this case it's not possible because it's a /24, but if you had, let's say for instance that this was maybe like a slash, I don't know, let's make this a /20, 25. Let's just say 25. And we had another network out here, and that's going to be 10.1.12. What's it going to be? 128. And that would be the start of that address pool. So, or the start of that network bit. And that would be also /25. So, if I put that same command, it would advertise both of these interfaces. So that's something you have to understand. The network command is just telling the router what interfaces do I advertise out OSPF. So if we had multiple networks or multiple subnetworks in a network, then you would advertise that network like this, the 10.1.12 network. Alternatively, you could also have a second network command to cover each individual one, but this here would be the way to do it if you wanted to advertise all interfaces that began with 10.1.12. And in this case, that accomplished that goal. So let's go ahead and go over to our lab. And again, I'm pretty sure that theory there probably answered your question at this point. But let me just go ahead and run through the configuration. Just to go through the configuration. So, as you can see, I've already done the interfaces. So just for kickers here, I'm just going to go ahead and ping over and be sure I got connection to router 2, which I do. Okay, so let's go ahead and configure router OSPF 1. Okay, so that's going to be our process ID, and we're going to go ahead and network our loopbacks, and we want to be sure that it's the entire thing. So only interfaces that have exactly 1.1.1.1 on it will be advertised out into area 0. Perfect. So next would be the 10.1.12. That's 0. It doesn't matter what we put there, but all that we care about is that the first three octets are 10.1.12. That's going to be area 0. And lastly, it's going to be the 13 network, area 0. And that's good for that router. Let's go ahead and go to this router, and router OSPF 1. Let's do network 10.1.12.0. We should see, what did I miss here? Area 0 and network. And we saw that. You see that OSPF adjacency there. That means that the adjacency between router 1 and router 2 are now up. And I advertised the loopback on router 2 into OSPF as well. So now let's go ahead and do router OSPF 1. Let's go ahead and network the loopback first. for no particular reason, just to change it up a bit. And let's go ahead and advertise the serial link interface here, and we should see a network adjacency come up soon, and there it is. So now if I pop back over to router 1, now we can ping that loopback interface on router 3 and router 2. So we can ping 3.3.3.3 without a problem. And that is because if we show IP route, so now we have our connected interfaces here. So we have our 1.1.1.1, we have the 10.1.13 and the 10.1.12 networks, but also we have learned through OSPF about the all2s network and the all3s network. And as you can see here, you've learned it through its specific interface. So again, hopefully this answered your question, and if you go into studying into the CCNP and you start learning about OSPF version 3, this pretty much solves that issue, because now pretty much you do all of your advertising in OSPF version 3, which is for IPv6. You do that over the interface, and you no longer have to put in network commands. So if it was that way, you know, with OSPF version 2, which is the OSPF you're working on, then you wouldn't have an issue understanding it. But because things are the way they are, and because networking changes, you have to kind of know the theory, and you have to be able to figure out exactly what it is that a particular syntax means, even though it's not always very intuitive. So I hope you all enjoyed this video. If you did, leave a like, and I'll see you all next time. Bye.